Okay, so welcome to today's lesson. In this video, we are going to look at the classification of acids and also the physical properties of acids, right? So, classification of acids. There are different classification of acids, but we're basically going to look at four classes of acids here. The first class of acid is the organic acid. We have organic acids and the inorganic acids, right? So the organic acids, they are simply acids which contains carbon, usually in the form of COOH, in the form of the carboxylic group or the carboxyl group, right? Any acid that contains carbon in this form is referred to as an organic acid. So again, organic acids, they are acids which contains carbon in the form of a carboxylic group, and this is the carboxylic group, right? So examples of organic acids are amino acids, fatty acids, ascorbic acid, lactic acid, citric acid, tartaric acid, and ethanoic acid, right? So these different forms of acid, they are found in living materials, in living things, right? Some of them are found in plants, some of them are found in animals. For example, the amino acid is found in proteins, and you know protein is part of the human body, right? It's part of living things. So amino acid is found in protein, fatty acid is found in fats and oil, ascorbic acid is found in ascorbic acid, also known as vitamin C, is found in oranges, lactic acid is found in milk, citric acid is found in lemon, tartaric acid is found in grapes, while ethanoic acid is found in vinegar. So these are the different sources of these organic acids. We're still going to look at them again. So the inorganic acids, they are acids which do not contain carbon, or if they contain carbon, they contain it in the form of CO2 and H2CO3. That's triazocarbonate 4 acid. So any acid that does not contain carbon, or if it contains carbon in the form of these two, that acid is referred to as an inorganic acid. So the basis for the definition of organic and inorganic acid is the presence of carbon, right? Any acid that contains carbon, usually in the form of a carboxylic group, that acid is referred to as an organic acid, while any acid that does not contain carbon, and if it contains carbon, it contains it in the form of carbon 4 oxide and triazocarbonate 4 acid, that acid is referred to as an inorganic acid, right? So examples of inorganic acids, they are hydrochloric acid, triazocarbonate 4 acid, triazonitrate 5 acid, and tetraosulfate 6 acid. So these are the examples of inorganic acids, right? So we also have another class of acid, which is the strong acids and then the weak acids. So strong acids, they are acids that ionize completely in water. They are strong because they ionize completely in water. For example, hydrochloric acid, triazonitrate 5 acid, and then tetraosulfate 6 acid. So for example, when hydrochloric acid ionizes in water, it ionizes completely plus Cl minus. So it is ionizing completely to liberate all its hydrogen ion, and that is why it is referred to what? As a strong acid. Also, when triazonitrate 5 ionizes, it ionizes to liberate all its hydrogen ion. It ionizes completely in solution. So we refer to this acid as a strong acid. Also, when tetraosulfate 6 acid ionizes in water, it ionizes completely. It ionizes completely in solution. So we refer to as this acid as what? A strong acid. So tetraosulfate 6 acid is a strong acid because it ionizes completely in water. You can see the ionization equation, triazole-95 acid is a strong acid because it ionizes completely in solution, while hydrochloric acid also is a strong acid because when it ionizes completely. So then we have weak acids. So weak acids, they are acids that ionize partially in water or they ionize incompletely in water. Examples are ethanoic acid, right? So when acids like ethanoic acid, CH3COOH, when it ionizes in water, it ionizes to give you an ethanoate ion and a hydrogen ion. So it does not ionize completely to liberate all its hydrogen, right? So that is why it is referred to as a weak acid. So a weak acid is an acid that ionizes partially or incompletely in water. An example is what ethanoic acid. We also have other forms of the weak acids, right? Other examples of the weak acids, they are triazocarbonate 4 acid. This is an inorganic acid. It is also a weak acid, right? So when this acid ionizes in water, it ionizes to form hydrogen ion and hydrogen triazocarbonate 4 ion. So it does not ionize completely to liberate all its hydrogen ion, right? So that is why it is referred to as a weak acid. It is a weak acid. It is also an inorganic acid. Then another example of a weak acid is it. So when this acid ionizes in water, it ionizes to give hydrogen ion and then hydrogen tetrazophosphate 5 ion. So this is hydrogen tetrazophosphate 5 ion. So when this acid, tetrazophosphate 5 acid, when it ionizes in water, it ionizes to give hydrogen ion and hydrogen tetrazophosphate 5 ion. So you can see that this acid does not ionize completely to liberate all its hydrogen ion. So it is referred to as what? A weak acid. It is a weak acid. It is also an inorganic acid as well, right? So these are examples of weak acids. Other examples of weak acids, they are the organic acids. Most of the organic acids are weak acids. For example, formic acid. Formic acid is an example of a weak acid. We also have oxalic acid. Oxalic acid is also an example of a weak acid. Citric acid. Citric acid is also an example of a weak acid. So all these are examples of what? Organic acids. And like I said, organic acids, they are acids that contains carbon in the form of the carboxyl group, and this is what? The carboxyl group or the carboxylic group. Then the inorganic acids, they are acids that do not contain carbon, but when they contain carbon, they contain it in the form of CO2 or triazocarbonate 4 acid, right? So that's the difference between organic and what? The inorganic acid. So we've looked at 4 classes of acids here. We've looked at the organic acids, inorganic acids, strong acids, and the weak acid. So this is a table that shows the organic acids and their sources. So examples of the organic acids are amino acids, fatty acids, lactic acid, ascorbic acid, also known as vitamin C, citric acid, tartaric acid, and the ethanoic acid. So amino acid is found in protein, fatty acid is found in fats, lactic acid is found in milk, ascorbic acid is found in oranges, citric acid is found in lime and lemon, tartaric acid is found in grapes, and then ethanoic acid is found in vinegar. So this table is very important. It's very important and crucial. You can be asked questions from this aspect, that which of the following acid is found in oranges, you should know that it is ascorbic acid, right? Also known as vitamin C. Then this is a table that shows inorganic acids and their formula. We have hydrochloric acid. This is the formula HCl. We have triazonitrate acid. The formula is HNO3. We have tetraoxosulfate 6 acid, H2SO4. We have triazocarbonate 4 acid, H2CO3, and then we have tetraoxophosphate 5 acid. And this is the formula H3PO4, right? So, like I said before, these two acids, they are what? They are weak acids. Why are they weak? Because they do not ionize completely in water, right? They are weak acids. While hydrochloric acid, triazonitrate acid, and tetraoxophosphate acids, they are strong acids, right? They are strong acids. So all these acids are examples of what? Of weak acids, right? They are weak acids. And why are they weak acids? Because when they ionize in water, they ionize incompletely, right? So basically, organic acids are weak acids. Some of the inorganic acids are strong acids, while some of them are weak acids, right? So the next thing that we are going to look at here are the physical properties of an acid. What are the physical properties of an acid? So an acid has dilute acid. Dilute acid has sour taste. They have sour taste. If you have tasted a lime, if you have tasted lime tastes sour, right? That sour taste is as a result of the citric acid that is present in it. So dilute acid, they usually taste what? Sour. They have sour taste. So this is a very important property of an acid. You can be asked, how does acid taste? How does dilute acid taste? So dilute acid has what? They have sour taste. Then they taste sour. Then concentrated acid are corrosive. They are corrosive. If you turn a concentrated acid, for example, a concentrated tetraoxophosphate acid, if you turn it on a paper, if you pour it on a paper, it will eat it up. It will burn it off, eat it up. So because of that corrosiveness. So concentrated acid are what? Corrosive. Then acid turn blue litmus paper red. They turn blue litmus paper red. They turn it to red. If you put a blue litmus paper in an acidic solution, it changes it to what? A red color. So acids turn blue litmus paper red. This is a very important property of an acid. Then acids have pH less than 7. They have pH that is less than 7. The pH is an indicator. It's just something that shows how acidic or how alkaline or how basic a solution is. So acids have pH that is less than what? 7. So from the pH scale is usually from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So the pH scale is usually from 1 to 14. 7 is what? Is neutral. Is neutral. From 1 to 6 is acidic, while from 8 to 14 is what? Is basic or alkaline. So acids have pH less than 7. So any pH that is less than 7 is what? Is acidic. That's an important property of an acid. Then acids turn methyl orange red. The methyl orange is an indicator and it is orange in color. So when you turn an acid into, or when you turn a methyl, or when you turn an acid into a methyl orange, which is an indicator, it turns it to a red color. Then also the last property of an acid is that acid turns phenolphthalein. phenolphthalein colorless. They turn this indicator, this is also an indicator, right? They turn it into a colorless solution or a colorless color, right? So acid turn phenolphthalein colorless. This is very important as well. So these are the basic properties of an acid that you should know of. The basic physical properties of an acid that you should know of. Again, acids, dilute acids, they have salt taste. Concentrated acids are corrosive. Acid turn blue litmus paper red. Acids have pH less than 7. Acid turn methyl orange red. Then acid turns phenolphthalein colorless. So this is just a quiz that will help us understand this topic very well. So number one is, what color does methyl orange change to in an acidic medium? It changes it to what? To red. Very important. What is the color of phenolphthalein in acidic medium? It is colorless. In an acidic medium, it becomes colorless. How does dilute acid taste? It tastes sour. So you can see that this is very simple. Then which of the following pH indicates an acidic medium? A13, B8, C4, D14. So like I said before, that the pH scale is usually from 1 to 14. 7 is neutral, from 6 to 1 is acidic, and then from 8 to 14 is basic. So which of the following pH indicates an acidic medium? Is a pH of what? Of 4. Right? So with this, we come to the end of today's lesson. See you in our next lesson.